Hello students, my name is Sandeep Kumar Saini and today our topic is PN junction diode. In last lecture we will discuss about N-type and P-type semiconductors and today we will discuss about our component which are formed by N-type and P-type semiconductor. Normally PN junction diode are used in rectifier which is used to convert DC signal to AC signal. Today in our lecture we will discuss about their construction, their VI tested direct current, and direction of current flow in PN junction diode. First of all, I am sharing your PPT so you can easily understand what is PN junction diode, their function, and their characteristic. Wait a moment, I am sharing your PPT. Today our topic is semiconductor diode, or we can say that PN junction diodes. Today our outlines of today PPTs is introduction of PN junction diode, characteristic, analyzing of PN junction diode circuits, and their applications of PN junction diodes. First is introduction. In introduction, PN junction diode are formed by two type semiconductors, that is N-type and P-type semiconductor. After combining a two type both semiconductors, a diodes are formed that is known as PN junction diode. This diode is mostly used in rectifiers and their applications, and this is non-linear current voltage characteristics are formed in PN junction diode. This is unidirectional device in which the current flow in single direction in ordinary PN junction diode. It is just like a resistance. They have two terminals. First is P-type and second is N-type, positive and negative, name as anode and cathode. This is a physical structure of PN junction diode. As you are showing in your display, there are two types semiconductor, P-type semiconductor and N-type semiconductor. Both are connected and formed a device. This is a metal connector. This is a metal connector in which the two terminals are connected, that is anode and cathode. The positive terminal is anode and negative terminal is cathode. The most important reason which is PN junction diode is your bonding between N-type and P-type semiconductor. This is known as your depletion layer. In a depletion layer are formed when P-type and N-type semiconductor are combined and formed a single layer. This is your structure of PN junction diode. Next is our current flow mechanism of PN junction diode. As we already discussed in P-type and N-type semiconductors, in P-type semiconductor the majority layers are holes, and N-type semiconductor the majority layers are electrons. Or when we combine a P-type and N-type semiconductor, the device is formed that is known as PN junction diode. In structure, we have already discussed their terminals and internal form. First is PN junction diode in forward bias condition. The forward bias condition means that when positive terminal of diode is connected with the positive terminal of supply and negative terminal of diode is connected with negative terminal of supply, that condition is known as forward bias condition. In this bias, when positive terminal is connected with P-type semiconductor, in P-type semiconductor majority layers are holes. Holes are positively charged, both are same polarity, so they apply force inner side. Same as the other side, this is your negative terminal of your battery, and in N-type semiconductor the majority layers are electrons, and electrons are negatively charged. So these electrons are same poles with negative terminal. They apply force in inner side. Due to that, the depletion layer is thin. Layer is very thin, and current can flow between your device. In opposite side, this is your forward bias condition. So we can say that the PN junction diode can convert in forward bias condition. Next is PN junction diode in reverse bias condition. In reverse bias, the polarity are reversed. So we can say that P terminal of diode is connected with negative terminal of battery, and N-type semiconductor is connected with positive terminal of battery. Due to that, the holes in p-type, holes in majority carriers in p-type, that are attracted with your negative terminal of battery and apply a force on outer side. Same as it is, this is your positive terminal of battery, and the majority carriers of in n-type semiconductor are electrons, and electrons are negatively charged. They apply force in outer side. They apply force outer side. Due to that, the depletion width are thick. वो हमारी थिक हो जाएगी, डिप्लीशन लेयर थिक हो जाएगी. तो डिप्लीशन लेयर थिक होने से क्या होगा, हमारा कोई भी करंट फ्लो नहीं हो पाएगा इन योर डिवाइस. देयर आर नो करंट फ्लो इन PN ordinary PN junction diode in reverse bias. As you seen in a diagram that the depletion layer is very thick, so there is no sharing of electron holes in between P type or N type semiconductor. Therefore, there is no current in a circuit. Next is breakdown. Breakdown means that when large amount of voltage apply in a reverse bias, large amount of voltage in a reverse bias, in particular after particular voltage, current are rapidly increased in negative region. At that condition, the diode get burn out and it cannot be used again. That is known as breakdown. As you can see that the value of I is more than IS. IS is your saturation current. कितना करंट वो रिवर्स बायस में वो अपना हैंडल कर सकता है. अगर हमारा जो करंट की वैल्यू वो ज्यादा हो जाएगी उस केस के अंदर, आफ्टर ब्रेकडाउन द करंट हमारा क्या होगा, रैपिडली इंक्रीज कर जाएगा और डायोड हमारा बर्न आउट हो जाएगा. नेक्स्ट इज योर VI characteristic of PN junction diode. As we'll discuss in previous slides, there are two biases. First is forward bias and second is reverse bias. In forward bias, when this is a symbol of your PN junction diode. Forward bias, we can already study that in PN junction diode are connected in forward bias, it cannot connect in reverse bias. Or when we apply a voltage in forward bias, slowly when we increase the voltage, first of all there is no increase in voltage. After particular voltage, the voltage get constant and current is rapidly increased, as shown in your figure in forward bias condition. After that, this is your reverse bias condition. In reverse bias, the voltage is applied. There is no current flow in a reverse direction, but there is small amount of current flow in a reverse bias. That current are flow with the help of your minority carriers. As we will discuss in last class, there are majority carriers and minority carriers. Suppose in P-type semiconductor, there are majority carriers are holes and minority carriers are electrons, and minority carriers are in N-type semiconductor. Majority carriers are holes. Due to that, there are small amount of current flow in a reverse bias with the help of your minority carriers. But after increasing the voltage of Vz, the current get rapidly flow. And that voltage is known as breakdown voltage. After breakdown voltage, ordinary PN junction diode cannot be used again. This is your VI characteristic of PN junction diode. This is most important question of your basic electronics, as we can say that your analog electronics, because one question always come from PN junction diode. The full chapter totally depend upon this topic. With the help of PN junction diode, the devices are found just like your rectifiers, your filters, or your clippers, clampers, and as you are already seen in your mobile chargers, there are four diodes are used in your mobile chargers, and that is a circuit of your full wave rectifiers. After that, the filters are connected, and the DC output are formed come out from your chargers, and that applied to your mobile phone to charge your battery. Next is direct current and diffuse current. There are two types of current, that is diffuse current and drift current. Diffuse current are formed when p-type and n-type semiconductor are connected. There is small amount of current flow at that time, that is known as diffuse current. There are small amount of current are flow because there are large number of electrons in n-type semiconductor and large number of holes in p-type semiconductor. When we connect both n-type and p-type semiconductor, the layer is formed that is known as depletion layer. And across depletion layer, there are small amount of recombination of electrons and holes. With the help of recombination of electron and holes at depletion layer without applying the external source, the small amount of current flow, that current is known as diffuse current. And in other side, the drift current is applied, and this current is come out when the external voltage apply on PN junction diode. With the help of external voltage apply, the electrons and holes are recombined and current can flow in a circuit that is known as your diffuse current. Or when this is your difference between direct current and diffuse current. And next is the application of diodes. The main application of diode is rectifiers. There are different type of rectifiers, that half wave rectifier, full wave rectifier, your peak rectifier. And the second application of PN junction diode is your clipper circuits, clamper circuits, and wave shaping circuits. All are formed with the help of PN junction diode. Or when we want to flow the current in unidirectional, that condition that condition we apply in your PN junction diode. This is your references, and thank you. If any student have a doubt in any topic, then you can mail me or WhatsApp me or call me according to your convenience. Thank you.